check, voice check, video check. Good morning, everyone. Welcome to another episode of Xah Talk Show. So we are going to do Wolfram language coding today. Wolfram language, I'm going to give you an introduction. I'm going to tell you where to get it. I'm going to then I'm going to talk about Wolfram language strings mostly. Today we are going to focus on Wolfram language strings and text processing. And we are going to code a live coding of a script. So Wolfram language, that's the main topic. And I'm going to show you in the beginning this keyboard, this fantastic new keyboard, okay? KEMOVE K68, butterfly keyboard. Now, voice check, check, video check, check. Okay, how are you guys? This is a great Sunday afternoon. Yes, fantastic new keyboard. So this is the one, KEMOVE K68, butterfly keyboard. Now, they are coming out in about 3 days, okay? So they send me a copy and you know, I'm gonna give you a review, 5 minutes review, short. Okay, so let's turn on, let's see, yeah. So this keyboard, okay, fantastic, a great build quality, you know. So, you know, you can just go to my Xah blog right now. You know, I just created this page today, so if you search it, you won't find it. But go to, you know, let me show you, okay, so go to xah.info, okay. Now there's a new search button. There it is, topic search. Click on that, and you just type keyboard. Oh, you need to turn on JavaScript, of course. JavaScript on, then type keyboard, you know. As you type, the result showed up. This is fantastic feature, JavaScript and TypeScript, Microsoft TypeScript. Excuse me, I still have a little cough from cold. So fantastic keyboard. So search, you know, search. I did a video, you know, about last month on implementing the search. So this is gonna search all the titles of my, you know, 4,000 articles. So you just type for keyboard, you know. So there are 523 results. Now you can type, you know, there's lots of Xah Talk Show, Xah Talk Show, Xah Talk Show keyboard, Xah Talk Show. So you wanna minus talk. There's still 458 results. Then you minus Windows, you know, minus Windows, minus Linux. Too many. So instead, you want a keyboard blog. Okay, so type for keyboard. Well, type for KEMOVE, KEMOVE. There it is, KEMOVE KDK61. Now this is a same maker, same brand. They sent it to me from China. You can buy on Amazon. And this, first of all, they have great, fantastic build quality, solid, heavy-ish. You know, I'm gonna show you. Okay. So anyway, this is the previous one, and it's fantastic. Okay, of course, it's 60%. I don't like 60%. No arrow keys. No function keys. I mean, they have virtual arrow keys, virtual function keys, virtual page up and page down. It's no good, okay? So, but, you know, if you like 60%, this I recommend. Highest quality build, colorful, you know. I'm gonna show you colors, okay? So colors, you can see this one, they got, wait, what's the key for switching to colors? You know, so many color variations, like so many. And they have the color on the side. But anyway, so this is their previous version, KEMOVE DK61. And then you go to my keyboard blog, scroll down, blog, and you can see today's, I just created this page today, and you have, you know, they have the side color as well, the strip on the side. And it supports wired if you want to, wired USB-C plug, or USB wireless 2.4 gigahertz. You press the switch. I'm gonna show you. And or Bluetooth. And if you switch to Bluetooth, you can connect to up to 3 computers. Okay. Now the color is. Let's see what's okay. So many color variations. So now I'm going to. You didn't see my shit. I forgot to show you my website page. Shall we do it again? Okay, so okay, let me show you. I want to show you this. Okay, so you go to xahli.info. There it is, and the top you have the topic search. Click on that, then you can type then turn on JavaScript. Yeah, KEMOVE. Then you have the article that shows the KEMOVE K68. This is a previous version they made, and the current model K68 is coming out. Okay. So anyway, I want to show you search. Okay, search. As you type keyboard, there are 500 results. Search from thousands of my articles. So you arrive at the keyboard DK61, then click on blog. Then here is the new page I created today, so you can see it. Great. So they have the site. So okay, now let me go back to the full screen. So let me show you. So quality build. Okay, so they have so they have the site color. So let me show you. Let's see if we can change the site color. Oh yeah, I know why it's not working. It's not, you're supposed to press the FN key, then press the caps lock. That will cycle different coloring of the site strip. Okay, it goes all around it. But why is it not working? It's because, let me go, complicated keyboard technology, this Xah system. So the reason it's not working because I have remapped the caps lock to Xah flag keys. So you get onto this page. This is PowerToy, a great tool for keyboard and other things. So keyboard managers, so you can see caps lock is now become home. That's why it's not working. Now let's turn it off. Okay, turn it off. Then go back to the full screen. Now let me show you. Okay, press the function key, caps lock, and press off and close. Okay. Okay, now wait, why is it yeah, so you can change the color by this key. Let's see, this is turn it off, turn it on. Switch to great varieties of coloring. And why is this? Oh, so this is one shot bomb. Ooh. Okay, so change the keys. So what is this? Let's press S. Okay, so that's that. Change the settings. Now what is this? Okay, change again. Now it kind of goes like that. Change it again. It's randomish. Change it again. Okay, candy stripe. Change it again. This is color shift. Change it again. Okay, let's stay with this. Okay, but how do you get the side strip to? I can. Let's forget about it. Let's see. Let's switch to 2.4 gigahertz, maybe there. I don't know why is it not working, but yeah, well, it was working before. Oh, okay, now it works. Wait, does it? Yeah, there it is. So now it shifts. You can see it moves around, it goes around. And next, okay, then next, what is this one? Oh, this is just steady. Next, anyway, the side coloring of the strips, okay, let's turn it off because it wastes battery and generally useless. Okay, I don't want to move and turn it off. Okay, turn it on. Yeah, okay, let's leave it like that. Okay, so let's turn the lights back on. And let me show you. So there it is, great quality, okay? There is the feed you can see, and highest quality keycaps, PCB or PCP keycaps. Anyway, and it's using thin profile keycaps. Let's see, my lousy, stupid camera, it doesn't focus. Anyway, so I just want to show you a bit of the keyboard, okay? And you can read on my page, you know, I have higher quality photos, and in the next week, in the next few days, I'm going to add information, and it's fully programmable, so it's fantastic, okay? And it's, by the way, it's hot swappable keys, so you can, if you don't like this switch, you can buy another switch. You can buy from their website, okay? That's that for that. Let's continue. Let's get on to, okay, we talked about keyboard for 20 minutes almost. Let's get on to Wolfram language coding. Any questions? Okay, language, so Wolfram language coding. Now let's get to the technicality, technical computation. So Wolfram language, I did many videos before, so you can just search for Xah Wolfram language tutorial, you'll find my page. I did over 10 videos in the past year, so covering many aspects of Wolfram language, the graphics, the power, the artificial intelligence, the generic introduction. This video is great. You know, the characteristics of Haskell, Python, Lisp, Mathematica. And I talked about Stefan Wolfram, a guy I admire his point of view and accomplishments. So, you know, I did several videos, so check them out. And the Wolfram graphics, you know, I did this one, fantastic geometry, you know. So you want to learn mathematics, real mathematics, not programmers, idiotic programmers. Crap. You know, whenever programmers talk about math, they talk shit. They don't know what they're talking about. So here is real mathematics, okay? Group theory, abstract algebra, topology, those are real mathematics, not programmers' algorithm. That's a different thing, okay? You know, in general, programmers know nothing about mathematics, but however, they adore mathematics. Anyway, so Wolfram language, you know, so here's the geometry. It's not exactly the traditional mathematics, but it's inversion. You know, it's the inversion, the topic of geometric inversion is a classic mathematics, but however, we are doing graphical programming, and this is, by the way, this is, I'm very proud of this one. This one is creative, okay? You will not see it elsewhere. So 3 tiles. So let me just show you Wolfram code, since we are going to, let's do some fancy, okay? God. So new keyboard, so I don't have the macro set up. So let's copy the code, and let's start Wolfram desktop. Okay, so today's focus is actually about string, text processing and string in Wolfram language. But let me just show you this, okay? So here is the Wolfram language code. Let's magnify. Am I doing good? Is it interesting? So, Windows, idiotic Windows. So you see, here's the code. You can, okay, let's run it. Shift return, shift enter. There it is. There it is. This is the process of how you generate this image. So I did a full video, 1 hour on this thing. How do you program this and what does it mean? And here you can magnify and you can rotate it. And this, what is this good for? This is good for modern decorative, interior decoration. If you go to art school, you can major in that, interior decoration. So what is this good for? This is good for garden tile design. Imagine you have a big house. Many of you, those of you who work at Google, or Facebook or Microsoft, programmers make a lot of money. So you're gonna have your own house and you can have a garden, design your own garden tiles. So this is one of them. Now you see this, the interesting part about these graphics is that you can see kind of circles going on. You see circle, 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 circle. That's the gist. That's why this image is interesting. You can see circles going on, yet the tiles are evenly distributed. Now this is based on geometric inversion, so I won't be talking about it, but watch my previous video. You can see geometric inversion of a square grid, then you get that. But however, what you want is that you see this image, you notice that things in the middle becomes tiny, as when they get closer to the origin, they become infinitely small. So that is not what you want if you want a garden tile, because you cannot have infinitely small, although this is pretty, but so you want to find a way so that you maintain the overall design, like circles like that, inversion of a square grid, then you get that. But however, you want them to be equally distributed and not getting smaller in the middle. So by understanding mathematics, you can figure out how to do that. So this is your basic, if you have studied calculus, like typically you go to school, you study calculus about speed and, you learn things. But this is the application. This is the application of the analytic geometry you will not see in school. But you need to understand it in order to do this. So what you have to do, what I have to do is to apply a transformation, first of all, you have to think about, you have to understand how this works, how exactly they get their position. Then you have to, once you know, you can come up with a transformation function to the whole plane. Then you start with that. Then you apply the geometric inversion. Then you get this. You see, now it's evenly distributed, these squares. And then you, with Wolfram language know-how, which is what I'm teaching you today, then you can get the 3D version of the tile, okay? Interior design. So this is, consider, it's part of applied mathematics, interior design, okay? When you look at geometry, so I'm going to talk random a bit. So Xah, you search for Xah, actually go to xah.org, okay, xah.org. Huang Nguyen, the expert of Malaysian Zoomer, give animation. Are you going to make an animation of me creating my keyboard today? So you go to xah.org, then you go to okay, I actually so then you go to visual arts. Okay, now I talked about this a few times. The visual arts, so you have the solar power, solar power, massive. So visual art, anyway, visual arts, then you go to what we want, architectural beauties, okay? There it is, geodesic domes. Now, here you have several geodesic domes. This is all geometry, geometry. So applied mathematics or decoration, interior decoration, architectural design, So when you study mathematics, when you study calculus, you thought, oh, it's boring. But this is a application of it, okay? And we are not even getting into the engineering aspect of it, because once you have design, buildings are not just like, you cannot just create any shape you want. You have to make sure they are stable, the material science, the engineering, the stress testing, that's deep engineering involving lots of disciplines. Okay, so actually my volume is a bit slow before, right? I mean low. Okay, so architecture, okay, and I wanted to show you architectural beauties. Okay, so these are all architecture. The beauty, there are so many styles of architecture. You have the Western style, for example, cathedrals. This is a classic European grand architectural design. Cathedrals, okay? Here you are seeing cathedral ceilings. They are deeply involved with geometry and mathematics, okay, deeply. So, you have different ceiling designs. This is an old castle. This is a beautiful girl, I know. 15 years ago, she sent me this photo. Beautiful. She's Italian. She's actually Palestinian and Mexican hybrid. Okay, beautiful. So she went there. She lives in Italy, and she sent me, a castle. Like lots of nerds. We used to, nerds of the 90s are very much into these things. I used to buy, study architecture. And here is an Islamic styled thing. Again, geometry. That's all you see, geometry. So my point here is that architecture, the gist, the essence of architectural beauty is geometry, okay? So you have the Western style, and here again it's a Western style kind of thing. Vaults, how do you call those? There's a name, specific name. This is Morocco. I believe it's called vaults, okay? So anyway, cistern, yeah, it's called cistern. There's a purpose, beautiful, fantastic. Look at that, beautiful. You don't see these kind of things today. So then, and we have more cathedrals. Now this is the most famous, the Cologne Cathedral in Germany. Grand, this is like 1,000 years ago. Grand buildings, imagine technology 1,000 years ago. It takes a few hundred years to build this. So again, my point here is that the essence of architectural beauty, when you think about architecture, many photographers, into architecture, you often see them, right? Design or churches. So what is the gist of the beauty? So why is architecture, sometimes, so many people into it? What's the gist? The gist is geometrical beauty. Okay, that's what I'm telling you. You don't hear that much from anywhere else. Okay, so and then again another Western architectural beauty. Okay, grand Baroque, and you can see and look at this design, exceedingly beautiful. By the way, if you don't know, okay, because I'm into math, I was looking at this, I was studying these things 20 years ago in 1990s, and I did, if you go to my website, Xah Math, you'll see quite a few of these, but they are pretty old. Xah.info, okay, then topic search, then just type math. Math, okay, so a lot of Xah talk shows, so minus talk, okay, 105 articles, okay, pretty math, for example. If you go to my website, you'll see I have quite a few, hundreds of articles on mathematics. This is related to hyperbolic geometry, this lamp, and and this is projective geometry, all sort of beautiful things. And this is related to topology, the claim bottle. And here is related to tiling and patterns, symmetry, group theory, okay? And this is just a tire print on the snow, but it's just exceedingly beautiful, the patterns, the pure geometry, just by lines and position of lines and stuff. Okay, so I have quite a few. And here, you see this one, water falling down from this mushroom structure, and they create this pattern. Now that's physics, okay? That's deep physics. In order to explain this, it's not easy. So someone, a physicist professor, actually explained this thing, water curtain, okay? Again, for example, what's the purpose of this? The purpose of this thing, this fountain, is exactly just decorative, beauty. That's why, if you just go out your neighborhood, wherever you live, okay, usually, typically in a city, you go out, you see all sort of buildings and buildings, and they have particular design. And what's the purpose? What's the functionality of their design? Why can't they just all be just squares? Well, because we cannot tolerate just boring. We kind of have to have beautiful design. Beauty is the essence of humanity. One of the first fundamental core of the meaning of humanity. Okay, for example, we look at the keyboard. Why should the keyboard have lights? Beauty. Okay, just about everything. Again, I'm digressing over. So today, I'm not sure we're gonna do Wolfram language coding. We're supposed to, because I already talked for 40 minutes about random things. But architectural beauty. Okay, and here's another one in a what is this airport? Dubai airport. So all relates to math. Okay, so but I want to go back to architecture. So I showed some of the Western architectural beauty. Then there's modern ones. For example, this one in China, this kind of roof, kind of for shading purposes, that's their purpose. But however, they designed it so that it forms stars. Fantastic. So, if you are how are you gonna do this? Who what make you think of things like this? What made you think? Or similar, all the others. What makes you think this is a modern church? Hyperbolic. This one is called hyperbolic. Hyperbola of One Sheet. Okay, where is it? Okay, I have tons of material and the math aspect of it. I'm not, I don't have a link here. I should have somewhere, okay? That links to the mathematical surface called hyperboloid of one sheet. This structure is called hyperboloid of one sheet. Okay, Xah. Okay, let's see xah.info. Okay, so again, you click on the search, then search for HYPER. So you have hyperbola. We talked about Hilbert curve, hyperboloid. Yeah, actually, I did a we did a live coding of this thing. Hyperboloid of one sheet. Okay, and here is the article. Here is the mathematical structure. It's made of straight lines. This curved surface is actually completely made of straight lines. Fascinating. So that's the beauty of mathematics. Okay, so and then you have this building and you have this tower and quite a lot of applications. Okay, so let's go back to architecture a little bit. Let me just complete. Okay, so architectural beauties, hyperboloid of one sheet. Okay, that's the kind of modern design. This is not, this is a church, this is a cathedral, I believe, Catholic church, Catholics temple of worship, in Brazil. And so it's called cathedral. And then you have, kind of modern. So this is kind of, this one, the beauty, this one is in China, became very famous back in the Olympics, China Olympics 2008. Its nickname is Bird Nest. It's I believe it's a stadium. Okay, but look at, it's beautiful. So, the most of the others, their beauty came from symmetry. Okay, you got that. Most of the others, their beauty can, for example, here's an Islamic style design, symmetry. You see, because it's symmetric. Most vast majority of buildings, this came from symmetry, because you can see there's a repetition. There's various types of symmetry. If you study group theory, then that is the topic of study of symmetry, group theory. Okay, you study math for a few years until you graduate, get a math major, focus on group theory. It's all about symmetry. You might be wondering, symmetry is so plain. So what else is there to study about symmetry? A human face is symmetric. You can see my left side and my right side is symmetric. That's symmetry. Okay, that's one type of symmetry. This star, so that's group theory. Okay, so that, I'm telling you, I'm enticing you into the realm, the beauty of the realm of mathematics. Because if you go to you just go to study at school math, oh my God, it's so boring. It's trigonometry. What you gonna do with it? Measurement, the distance, and it's so boring. I'm giving you the interesting parts. Okay, so symmetry, that's group theory. So I'm talking about this one. So all the others are symmetric. What's this thing? This thing is not symmetric, but it's beautiful, but it's not symmetric. It's like random lines. That is the beauty. The beauty of this one is order within chaos. You see, if you actually just random, pile a bunch of bricks together, it's not beautiful. But however, you have to make it such that it seems like random, but there is certain order, within. That is this thing. That's the essence of the beauty of this design. Okay, that's that one. Okay, then we have the cooling towers. These are again hyperboloid of one sheet. Then you have this kind of more humanistic. It emulates the shape of a tree. This China, China is becoming incredible in past 10 years. They have tons of these kind of buildings, tons. Then you have these, this is also beautiful, So architectural beauties, the essence lies in geometry. You see, there's a cone that forms the conic sections. Came from a conic sections. Okay, I think that's that. Then we have more non-geometric based beauty, such as kind of the sculpture. This is in USA, beautiful. Okay, so I was saying what? Greetings from California, Arnold. Hello, Arnold. Are you the guy on Discord, I think? Maybe the... Okay. So now, how am I doing? 9 people watching. Okay, now let's maybe do Wolfram language now. Okay, let me have a drink. Then let's do Wolfram language. Okay, PC keyboard. Let's see. Yeah, Wolfram language. Okay, so yeah, PowerShell. My PowerShell tutorial. How to unzip. How to untar. How to ungzip. Using PowerShell. So I continuously update my programming language tutorials. So if you like my stuff, pay me, okay? PayPal and Patreon. I have links on my website. If you like my stuff, pay me. Emacs, all these are great. Emacs, Lisp, Wolfram language tutorial, which is what I'm gonna talk about today. HTML tutorial, Visual CSS. All these are great, and JavaScript in depth. That is the most effort I've took, the most in-depth coverage of the most complex language, JavaScript, more complex than Emacs Lisp. So this is, this tutorial is great. I spent like 2 years full-time writing it, and here is the KEMOVE K68 keyboard we talked about earlier. Fantastic. Okay. So my, and Golang is my favorite language, kind of, favorite industrial language. PowerShell is also great. PowerShell is a magnitude better than Bash, better than the Unix shell crap that is 30 years of baggage. Shell, T shell, C shell, TC shell. In the beginning it's a boom shell, SH, boom shell, then bash, boom again shell, then C shell, trying to make shell into the C language syntax, because C and Unix, they piggyback on each other. They are the virus, the C shell. Then C shell is crap. Then someone created TC shell, which is improvement of the C shell. Bash, boom again shell is improvement of the boom shell, SH, the original. Then, a bunch of shells. Then you have scheme shell, SCSH, a bunch of. PowerShell is a magnitude better than all of them. From a design point of view, from the programming language design point of view, and from the power point of view, what can it do? And from many aspects, from the documentation aspect, the PowerShell documentation is far more superior than the Bash crap, the Unix fuck. Okay, PowerShell. In every aspect, PowerShell is superior. Okay, I know many of you, the Linux idiots, you're gonna say, "Oh, Xah, but you are wrong." Oh, sometimes I get some people, Unix fanatics, they watch my video. Then they came upon a passage where I say the Unix are idiots, the Unix operating system are idiocy, extreme. Then they are surprised. Oh, Xah, you lost all credibility. No, you haven't watched enough of my videos. Let it get into your mind. Let it absorb. Listen to what I say carefully, okay? So PowerShell is a magnitude beyond, the Bash crap. PowerShell, in just about every aspect, okay? Every aspect. PowerShell, and now it's open source. It's Microsoft open source. The greatest contribution to open source by lines of code, by number of projects. Microsoft, thank you, Microsoft. Great pillar of humanity. The ethical quality of Microsoft. Even Richard Stallman, stand in Microsoft buildings, standing in Microsoft podium, talking about Microsoft. Yeah, that happened 2 years ago. I have an article on that. Okay, I'm gonna start Wolfram language, I guess. So there's a question. Would you suggest using PowerShell in Linux? I'm one of the... No, you are not, okay. So would I... Well, you see, when you decide on a language, there are quite a few aspects. Now, like what I said before, PowerShell from a technical point of view, is a magnitude better than bash, okay, or TC shell, okay, or Z shell, some Z shell is one of the shell that you have lots of fans, Z shell. These are old to me because I'm old. I'm 50 something. So like 20 years ago, 30 years ago, I'm immersed into this debate about shells. Today most you guys Zoomers don't know what the fuck is C shell. You never heard of. What is TC shell? You never heard of. Oh Z shell you just heard of because Apple switched to Z shell. Anyway, so I'm old. So anyway, I was saying. So the question, should you use PowerShell on Linux? So first of all, I say that PowerShell, from a design point of view, from the power, from the documentation, it's far more superior than Bash. But however, on Linux, should you use PowerShell? I mean, it's open source. Okay, my answer is that that depends. Okay, here's an interesting part. Why? Because if you think PowerShell is so great, technically speaking, why is it not? How come you don't recommend PowerShell on Linux? Well, the reason is, you see, Linux is a operating system, right? Basically, the point is that typically on a certain operating system or platform, you want to go native, okay? You want to use whatever technology that's native on that platform, and that has a significant advantage, okay? That is my reason. Okay, so PowerShell, even though it's great, but if you are on Linux, you will run into, so this is a social aspect. This is kind of social, not technical. Technically, PowerShell is superior than Bash, period. Okay, period. Better documentation, better power, better flexibility, better than Bash, period. The fucking idiotic fuck Unix Bash. Those of you Unix fanatics or Linux fanatics, Windows tiny managers, you're gonna object, you're gonna shut the fuck up. You don't know nothing. So PowerShell is technically far superior than Bash, okay? However, there's also social reasons you need to consider when you make a choice, of a tool. So what is the social reason? Because you in general, you want to use a technology that's native on the platform. Why is that? Because, for example, on Linux, on Linux, PowerShell is not installed. It's not installed, man. So whenever you write something in PowerShell, other people cannot use it. You have to tell them to install it. That's an extra complexity. Okay, they rather just start, just tell them to type something they can use right away. So that's a problem. That's a reason. That's a social reason why something is technically superior, but there are reasons sometimes you don't want to use it. Okay, that's one of the reason. Social reason. Okay, PowerShell is not installed on Linux. That's one of. There's more. So just like Emacs, Emacs is not installed on Linux neither most of the time. That's why there are so many Vim users, because Emacs is not installed. It takes extra step to install it. With that, it comes complexities. But because, for example, but how do you install it? There are different choices. You can install by Linux, the Ubuntu package system. There's then on Arch Linux or different Linux, there's different package system. On Linux OS, there's another different package system, and then there's more complexity because some of the package systems, they don't use the latest version of Emacs. Emacs 28, fantastic, is released this month, but in April. But many of the packages on Ubuntu package or Red Hat package, they are not updated yet. So there's a complexity. That's one of the reasons. So back to the question. So that's why usually it's better. There's a significant advantage when you stick with whatever that's native. You want to use the native technology. So On Linux, the native technology is Bash, okay? So you might, so that's the reason you might to consider not using PowerShell. So but which one should you choose? Then it depends on lots of things. What's your situation? If all you do is gonna just for yourself, then you might take the trouble to install PowerShell and master it. So you can use the same language on Mac or on Windows or on Linux. But you see, the thing is, on the Mac, the default shell is TC shell. I mean, it's Z shell today. So it's not Bash. So on Linux, you might use Bash, but on the Mac, you might use, you might stick with Z shell. They are mostly compatible, but not exactly. So there's, complexities. Okay. So there's a question, why is PowerShell better? I did a video before, but people don't look into things in depth. Like the question gonna come up over and over again. I'm gonna answer today. By next week, somebody will ask me, what do you think PowerShell is better? So I'm gonna do it all over again. So there it is. You see that link? Why PowerShell? Why I love PowerShell? Here's the reason. Okay, so you can read that. Okay, I'm not gonna explain it today. Fantastic. Thank you, Reaper. Reaper has been great guy. Reaper has been my loyal supporter. Thank you for the donation. So Reaper's question, what should JavaScript or PHP borrow from Wolfram regular expression to make regular expression better? Okay, that's a good question. That question takes some time to explain. Let's see. Okay, I almost already talked for 1 hour. So, that question is what I'm supposed to do today. Let's see, where is my Wolfram language, so I'm supposed to talk about tutorial and coding of Wolfram language on string text processing, which will include, I was going to cover regular expressions. Okay, so, God. Okay, let's talk about that. Yeah, so the question is, what should JavaScript or PHP borrow from Wolfram regular expression to make regular expression better? Okay, so we talked about on Discord a little bit about that. So, but in order to explain them so everyone understand, it'll take some time. So the thing, okay, let me do. Okay, so regular expression. First of all, you have regular. So let me answer that question full in 10 or 15 minutes, and that's it for today. Thank you, Reaper, and thank you guys. So first of all, you have regular expression. So let me show you. So you go to Xah. Okay, let's go to Xah info. Let's go to the topic search again, because I'm going to show you my index of all my articles about regular expression. I have written 40 articles. REGEX. Okay. So there's 37 results. Python regular expression, Xah talk show on regular expression, Wolfram language regular expression. Okay. PowerShell regular expression reference, Perl regular expression. So, but there's an index. Okay, so let me go to it. Where's my index? Perl regular expression. Okay, so let me answer that question, and that will be it today. Emacs Lisp regular expression, closure regular expression limits, or should you read mastering regular expression? JavaScript regular expression, 10 articles. How to improve Python doc? Okay. Why is it not? Oh, okay. So you type, instead of regex, type regular. Quite a few articles, and here's a great article. This is 20 years old. Let me show you that. Perl, Dr. Ilya Zakharevich regularly expresses. This is an article from year 2000 by this guy, very famous Perl programmer. He excuse me. So he is a, this is 20 years ago. So he was very famous back then. He wrote much of the regular expression feature in Perl. And Perl is the language 20 years ago. It made regular expression popular among programming languages. Okay, so anyway, let's get back to focus. Okay, where's my article? There it is, Xah regular expression article index. So here's a collection of all my articles related to regular expression. Okay, so what I want to say is, so most of you are probably familiar with regular expression. So let me show you some, let's go to my JavaScript regular expression. So JavaScript regular expression syntax. So what is regular expression? Well, it's a syntax. It's a little language. It's a syntax that represent a string pattern. Most of you probably already know. So here's an example of JavaScript regular expression syntax. Okay. Now regular expression syntax is similar to it's similar in most industrial languages. So you have JavaScript, Python. So for example, here's the actual code. So if this is the text, okay, let's magnify. Yeah, I cannot. So for example, this is the text, and if you want to extract email addresses from a text file, you use this pattern. This is regular expression that will, match that represent the pattern for the email form. So that's what you use regular expression for, very powerful, okay? So all these languages, their regular expression syntax are similar, okay? All these JavaScript, Python, Golang regular expression, here's an example. You want to extract certain things, email numbers or image tag, or, for example, in HTML, you have image tag. Anyway, so you know what I mean. And Emacs, okay. So the regular expression syntax are all similar, okay. So let me show you a let's see, PowerShell. Where's my PowerShell regular expression? Oh, I didn't include here. Anyway. Let's go to Emacs Lisp, okay? Emacs regular expression, because I have kind of a summary, okay? So here is a summary of the regular expression syntax patterns. For example, here's a match one or more digits. Here's a match one or more non-digit. Here's match one or more English alphabet letters. And there's also, repeat one or more times, repeat 0 or more times, repeat a pattern 0 or 1 time, and so on. That's regular expression. So the syntax is similar in all these languages. Okay, and so one of the things people complain about regular expression is that they are hard to read. Let me show you an example. Xah info topic search. So search for tooth. So you got Bluetooth, you got Emacs Toothpick syndrome. That's the one I want. That's the one we want. So you are looking at regular expression in Emacs Lisp. You see that thing? That string, that's a regular expression. What does that do? That one tries to extract a link in HTML file, a link with images, a link or images. You want to get the URL of it. So you are looking at regular expression. In particular, in the Emacs Lisp flavor, okay, they are all similar, but Emacs Lisp, they are all similar. So one of the common complaints about regular expression is unreadable. Okay, so like that. Like what the fuck, it's hard to understand exactly what exactly is trying to extract a pattern, And another problem is the toothpick syndrome, like slash and backslash, going crazy. So we have a world record here. Okay, look at these guys. Okay, Emacs Lisp. This is Emacs Lisp. This is part of Emacs. I can actually show you. This is sub.r.el. I can show you the code, but no need to. Okay. So just screenshot is enough. So you have the toothpick syndrome, because you need to escape the backslash is escape. You need another backslash to escape the backslash. And if you want to if you need to, for example, if you need to match the Windows path, okay, pwd. Let's go to web. Okay, cd web. Okay, let's say Emacs. Okay. Okay, so there's you need to go to Sali info, then Emacs. Okay, so you started to see lots of backslash. So if you want to, by the way, Windows also supports slash for the path separator, directory separator. But if you're gonna need to match this, so you're gonna have backslash, you need to escape it. You're gonna have backslash Titus like that, okay? 17 backslashes here. Now, is that the record? I have, so there's a 17 backslash. Then there's, this is my own code, by the way. This is a package for BB, a BB code, the PHP language markup, very popular all over, in the year 2000s. So you have backslash like that. So anyway, that's the problem of regular expression. People complain, very common. It is unreadable, okay? Unreadable and backslash problem. Toothpick syndrome. This is known as toothpick syndrome. Okay, so programmers, including myself, 20 years ago, has been asking the question, who designed, which idiot designed the regular expression like that? Can't we just create a new, like, more readable syntax? That is the question, okay? There are two alternatives. One is Wolfram language. One is Emacs RX package, okay? So I don't have a code for Emacs RX. Let me show you, okay? Describe function RX, okay? There it is. That's the package, okay? There it is. So let's go to it. So first of all, read the documentation. So it says RX is an auto-loaded Lisp macro in this file, okay? So here's a function RX regex, okay? Translate regular expressions in symbolic expression form to a regular expression string. So what it means is basically it provides you a alternative, more readable syntax for regular expression. So for example, in regular expression, you have the vertical symbol for alternative, either this or that. So in this package, you can say this syntax to represent it, or. So basically, this package in Emacs called RX, you can use it. It provides you with a easier to read Lisp style, nested parenthesis, Lisp style syntax for regular expression, okay? for example, so yeah. Yeah. Now I need to, I'm using softline keys, so I need to turn on my caps lock remap again. So let's do that. So turn it on. So first of all, make sure it's off, then turn it on. Okay. Okay, so it provides a easier to read Lisp style syntax for regular expression. Okay. I want to, I forgot the command name. There it is. I want to highlight the current line. Okay, so it provides a alternative syntax more readable for regular expression. So that's one of the solution, and this exists in Emacs Lisp. Okay, so if you code Emacs Lisp, you can use that. However, it's, so basically there's the idea of a alternative syntax, more readable improvement syntax for regular expression is rare. So in Emacs you have that, but basically that's it. So as far as I know, there doesn't, there's not many. So basically you just learn regular expression and you get used to it. It's like learning a new language. After a while you start to get it, but still it's difficult to read. So there's another alternative, that is the Wolfram language. Okay, so where is it? Let me show you. So RX is an alternative and Wolfram language is another alternative. So where is my Wolfram language code? Okay. Yeah, so Wolfram language regular expression. So let me show you string pattern. So this is a new article I've written, Wolfram language string pattern. Okay, so in Wolfram language you can have regular expression like that. That's that's how you do regular expression. You call the function. Let me magnify. Okay, you call the function regular expression, and inside it you just give a regular expression string, just like every other language is regular expression. Okay, very similar. But however, Wolfram language provides you a alternative syntax for regular expression. Okay, first of all, let me show you this. Okay, so let's copy that. Let's evaluate. Since we are doing this, let's where's Wolfram language? Okay, so here's a Wolfram language, and also I want to show you. Let's turn this into mathematical format. Format it in a mathematical way, so you can see. So anyway, so let's evaluate that. Okay. So now let's open a new. Okay, then let's paste that. Okay, so here's a string. String cases is a function. It takes a string and it takes a pattern. So the string is like we have here a Unicode and ABC, and here is a pattern. The second argument is the pattern, and we call the function regular expression, which is a pattern in regular expression. So a dot in regular expression means any character. So if you just call that, it will return that. basically any one single character. It returns all the matches that's one single character. So that's an example of regular expression in Wolfram language. Okay, now Wolfram language provides a alternative syntax to represent string pattern. Okay, and that is called StringExpression. Okay, now I'm not going into detail, but anyway, so here you are looking at let's go to the Wolfram website. Okay, where is it? Shit. There. So here's the Wolfram website and StringExpression. So this is a alternative syntax for regular expression. Okay, so let's magnify. So you can see a single character in regular expression is a dot, but in Wolfram, string expression, it's a underscore. It means any character. Okay. Now, if you want any character repeated one or more times, that's 2 underscore, 2 low lines. And if you wanted to repeat 0 or more characters, it's 3 underscores. And this is how you give a name to a pattern, any pattern, and this is how you express alternative by either using a list or by using a vertical sign. So anyway, so if you want to represent white space, you type that, white space. If you want to represent a number, you type that, number string. So this is the alternative syntax to represent a string pattern. And the power is pretty much similar to regular expression, except a few things. For example, you see this any order, it allows you to represent a pattern regardless of order. That you cannot do with regular expression. Okay. Now, okay. Anyway, so that's the point. Okay. So this string expression. So let me, like I have showed example here. For example, let's do the same thing in Wolfram language. Okay. So for example, this one. So let's now paste it. You see, just these two are the same. String cases, this string, and instead of regular expression, we use string expression. Now let's evaluate it. Okay, you got the same result. So you can see that's a different syntax for string patterns, and they are almost the same. The power is essentially the same, but Wolfram language string expression is an alternative way to represent string pattern, and in general, it's more readable. Okay, so let me summarize. There are 2 alternative regular expression syntax that I know of. One is in Emacs, RX, we talked about. The other one is Wolfram language, string expression. Okay. So Reaper's question about whether they, what should JavaScript or PHP borrow from Wolfram regular expression? So basically they don't want to. Basically, the JavaScript, PHP, or Perl, Python. Basically, the industrial coders, they do not need. They are usually for them. Usually they do not find a need to do so. It is true that regular expression is a bit hard to understand. It's not as readable, but however, the industrial coders rather stick with one similar, one kind of universal, almost universal regular expression syntax. That's what I believe. Okay, now you could, of course, introduce the Emacs regular expression, RX. Let's go to RX again. you could introduce the, Emacs regular expression style or the Wolfram language regular expression style. By the way, there's a comparison here, okay? So here you can see the comparison between the regular expression syntax on the left and the Wolfram string expression syntax on the right. In general, the regular expression version is more terse. It's cryptic, but it's more terse, while the Wolfram language analog is more readable, but you have to type more or you have to use completion. So anyway, I think the industrial coders, they are not that much interested in a alternative regular expression syntax. That's what I think. So yeah. Okay, so that answers one part of the question. Let me answer another question, which is more important. I think you are asking. So when you think about regular expression, one aspect is the syntax. Okay, for example, you want a more readable syntax. Okay, so you have two alternatives here: Rx, Emacs, Lisp, Rx, or the Wolfram language string expression. Okay, two alternative syntax for regular expression. Now, the other question is the power of regular expression. I mean, so people, one of the supposedly flaw of regular expression is that you cannot use regular expression to match anything that has nested syntax. Okay. So for example, let's go to my talk show. So here's today's talk show. So you can see the figure, so you have the figure tag on our side, then you have the iframe, nested inside, then you have also figure caption nested inside. So if we're gonna show this in browser, it's the YouTube, embedded YouTube. So, but anyway, it's a nesting. So regular expression cannot match nested patterns. You might see programmers blog about it. It's like almost like a revelation. I just realized regular expression cannot. Or sometimes, elite programmers, they'll tell you, by the way, regular expression cannot be used for matching nested syntax. They say that as if it's a great new theory. They know. Actually, that's very silly, because regular expression, the origin of regular expression, the meaning, where does it came from? Who created it? Who created the concept of regular expression? So the regular expression background the regular expression background came from theoretical computer science of formal languages. I talked about this many times in my past video about proof systems. So again, regular expression came from theoretical computer science. They are trying to, automata, the science of automata. Let me Xah info, go to topic search, AUTOMAT, automata. Okay, so MATA. Okay, so 8 results. So I did several videos on game of life, cellular automata, and universal machine, Europa, and Bool, Greek automata. Okay, I'm digressing over. There. The jargon of automata in finite state automata. Okay, this is very interesting. The origin of the jargon automata. It came from 2,000 years ago. Greek, the Zeus, the god of the Zeus, who fucked every woman. And he, so it came from the myth of the God. So I'm gonna talk for hours on this. I haven't get to my point. Are you still here, Ripper? So I was going to talk about the semantics of regular expression, the power of regular expression, but we got digressed into the origin of regular expression then digression into the jargon, the origin of the jargon automata. So I want to, so let's just talk, okay, talk show. Xah, Europa, and the bull. Okay, so Europa and the group, the bull, the great Greek mythology, the origin of Western society. Europa, that's the name of Europe, came from. What is Europa? She, this beautiful girl, that's Europa. She got abducted by Zeus, the god of all gods, the most powerful god, Zeus, and who fucked every woman. So Zeus raped, that's how they say raped, or the Europa, because she's beautiful. So Zeus, the powerful Zeus, the father of all gods, he changed himself into a beautiful white bull to, what's the word? Seduce. Yeah, you can say rape or seduce. That's how women and men relations are. You can call it rape or you can call it seduce. So a little bit. I'm not going to get into that. But the Zeus, changed himself into a white bull. Look at that. So that he can seduce this girl, beautiful girl. And once she hopped onto it, the Zeus just ran off. There's great poetry written about it and great artwork. So, for example, this thing, 460 BC, so 2,500 years ago. Okay, and here's a Europa celebrating, the Europe. Okay, the modern millennial Zoomers, idiot, fuck, don't know nothing. They just know about memes. But you don't see Pepe, Pepe and memes and whatever in social justice warriors. But you don't see this kind of this is meme. Okay, this is this is the ancient, the real meme. And look at this. This, thanks to Frenzy, our illustrious members in Xah Discord. Thank him for this photo. That's Europa. That's the bull. That's yours. Okay, in Europe you have this kind of thing. In America, no. How can you do that? The cultural differences. In Europe, where is this? Brussels, Belgium. You have this sculpture under broad daylight in a train station. You have this this BDSM style, Europa and the bull. That's Europe. Okay, so what does this have to do with regular expression? Well, Zeus seduced Europa, took her away. Then they had 3 children. Okay, great story. You can read it for hours. And Zeus gave her 3 gifts. 3 gifts. One is a giant automata. What is this thing? That's the automata. Okay, so let's go back to this thing. So what in Zoomer, in today millennial Zoomers jargon, that's called the mecha. Okay, that's called the mecha. Okay, a giant robot that protect her. It's a robot. So that's one of the gift Zeus gave to Europa. And there are 2 other gifts. One is a javelin that we will never miss, and another gift is a hound dog. Yeah. So anyway, so you can read the details. So what does this relate to regular expression? Well, the automata. That's where. So automata, it means a robot, okay, or a mecha, okay, a robot, a mechanical, algorithmically controlled thing. So back in 2,000 years ago, mythology, Greek mythology, algorithmically controlled robot. Okay, and the word automata became a thing in computer science. Machine, it means machine. Okay, so you computer science today. In the past 100 years, we started to have computers, and we study automata, so we borrowed the name automata to mean a self-functioning machine, a machine that works by an algorithm. It just, the commands and you'll run, okay, by itself, by algorithm. So that's a term that came into computer science, automata. You can look up on Wikipedia. So let's look up on Wikipedia. Okay, that's a movie. We don't want the new generation movie. Fuck. The Millennium whatever, Millennium Zoom. Fuck. So let's go to automata. So automata theory, tutorial point, a scum site. The commercial, cheap, mostly, lots of incorrect, for money tutorial. Fuck. If you want to read tutorial, read my page. There it is, okay? Automata theory, okay? Automata theory is a study of abstract machines and automata, okay? Let's click on automata, okay? There it is. The origin of automata, okay? Automata or an automaton, plural automata, is a relatively self-operating machine or control mechanism designed to automatically follow a sequence of operations, okay? So then you have automata theory, computer theoretical computer science, okay? So we have some examples of automata, and one of the earliest, 2,000 years ago, this Antikythera mechanism, very elaborate clock and astronomical thing, analog computer, okay, the 2,000 years old, automata. So automata became, originally it was mythology, so it got borrowed into computer science, okay, meaning a machine. Okay, so then we are back to, so then regular expression, where is it? The regular expression is about automata, okay? So in automata, so theoretical computer science, you have NFA and DFA. DFA means deterministic finite automata. Now, what are those things? Those things are the they are tied to regular expressions, okay? But anyway, so the origin of regular expression came from formal languages, and it's a way to parse a class of language called regular languages. And what is a regular language? A language is a language, basically a sequence of symbols, such that there's no nesting. Okay, that's a key point. What is a regular language? A regular language is a sequence of symbols that does not involve any nesting. The grammar does not have any nesting. Okay, that's regular language. So regular used is not for the purpose of matching nested syntax. Okay, that's the point. Okay, that's it for today. I guess we talked about 90 minutes now. So is my answer satisfactory? Do you have any further questions, Reaper? So on the question, why can't we create a regular expression, tool that does, that allows you to match, for example, HTML or Emacs Lisp code that involves lots of nesting, even C code, C++, Java. You have the braces, curly braces. Sometimes you need to match them. You want to find, for example, inner functions defined inside the function. So you want to find the curly braces inside the curly braces. You cannot do that with the regular expression. So the question is, why can we have a tool that actually do that? Just like regular expression, so you can easily, parse nested thing. Well, the thing is, no, it doesn't. Well, the thing is, it already exists. It's called grammar. Okay. It's called parsing expression grammar. It's called, let me go to it. Study.info. Search. Type grammar, and there it is. Formal grammar, formal language grammar, parser, ambiguous grammar. So you go to formal grammar. Okay, so let's shrink a little bit. Let's magnify. Okay, formal grammar. So click on that. So here's my kind of tutorial, kind of incomplete. I was trying to write a compiler. Before you write a compiler, you have to write a parser. Now, before you write a parser, you have to understand grammar. Okay, formal grammar. Why formal? Because it's formal language. It's part of the study of formal language. So you started to get into these topics because, formal grammar hierarchy. So you have, anyway, so formal grammar, so let me talk about formal grammar. Formal grammar here, BNF, okay, it's usually written in the syntax BNF, called Backus norm form, and several other variations, eBNF and ABNF. Okay, so here is an example of formal grammar. So in short, if you want a regular expression that can match nested patterns, that's what they are. This is what you have. BNF, Backus norm form. Okay, syntax to match postal address. Okay, like USA street address. You write it this way. Okay, and basically all programming languages has a grammar like that. Okay, you specify